Let's talk about security group and network ACL, and let's see how it protects our applications and EC2 instances. So we will first focus on what current infrastructure looks like. So currently we have a very simple infrastructure in terms of networking. We have a VPC in this IP address range 10.0.0.16. Then in each of the availability zone 1 and 2, or A and B as you can call it, you have put together subnet, public and private, and NAT gateway is there, and that's all is currently accessible. Route table exists and we are able to send traffic out. Let's add security component here. Now when I say add security component, doesn't mean that security not is already is not present. It is, but we want to now customize and understand how it actually works for us. So we have to talk about two concepts here. One is called security group and second is called a network ACL. Let me write it down here. So we will discuss about security group and network ACL, or we sometimes just call it NACL, which stands for Network Access Control List. They both are similar in function, similar in the sense that they both do IP level protection, they do network layer protection for our application. So we'll see how to use each of them, and they are not competing services or competing component. You would probably use both of them to provide security. Security is always considered a layered approach, so probably you have your workload here. You won't rely on only one layer of security for it. You may have one layer, maybe one more layer, and maybe one more layer. So it is possible to have multiple layers of security, and the same concept is implemented through security group and network ACL. Let's go ahead and see this thing through an example so that you could relate it. I'll take example here of the place where I live in London. So it's a multi-story building and the whole thing is into a campus like this. So if you could see, this is a gated community. Entrance is only from one place and we have security guard in every building. So if I'm coming from this entry, I would have to go through the security guard if I want to talk to someone here. So let's go ahead and keep this example at back of your mind that this is a gated community. Consider this gated community is your VPC. And these buildings which exist here, let's consider these are all my subnet. So this is my subnet 1, this is let's say 2 and subnet 3. So multiple subnets exist within a VPC. I'm trying to simulate the similar stuff here. And these apartments here, what you see like apartment number 4 or apartment number 6 or apartment number 3, consider that these are your EC2 instances which want to communicate to other instances or to outside world. Let's see how that communication would be happening. You could think of this gate as your IGW, which is allowing your traffic to go outside to internet, and maybe from outside traffic, traffic can come internally. That can also happen. So that is kind of IGW. But right now our focus is on security group and network ACL. And in these apartments, if you see this small black thing here, this is representing a door of an apartment. I'll give an example that what I'm trying to prove you here. So summarizing, your whole campus is a VPC, your buildings are subnet, and individual apartment are your instances and they want to communicate. Let's see how the communication would be happening. Let's take a very simple example. Let's say somebody who lives into apartment number 5 here, he or she wants to talk to somebody in apartment number 2. I'm talking about physically going to their door and knocking. So that is required, that people from apartment number 5 want to talk to people in apartment number 2 into the same building. In this case, as they belong in the same building, they would be able to go ahead and send requests to 2. They do not have to cross the security guard. Now, what they have to do, they have to come out of their door and knock on their door of apartment number 2. Now, knocking doesn't mean that you got access. Knocking means you can reach up to that point. Whether that door would open for you or not, that would depend on what person inside number 2 is thinking, or do they want you to allow inside or not. So that would depend. Now, what this door is representing here is representing a security group. So like every apartment has a door, similarly, with every EC2 instance, I could associate a security group, and in that security group, we create something called rules, and in that rule, we say which type of traffic has to be allowed. Like I could say, I want to allow port number 80. So any request comes on port number 80 on the security group, it would be allowed to come, right? So that is a security group. In this case, the communication from 5 to 2 is not subjected to security guard. They are communicating internally because it is within the building. So idea here is if your machines are communicating within the subnet, the only security control they have is a security group. Let's see another communication now. Let's assume someone from apartment number 3 wants to talk to someone in building number C here. So apartment A here. This person has to come out of their door, right? They have to go up to the security guard, and then from the security guard they have to come to this security guard and then venture inside the building. So that's how the communication would look like. In case of across subnet communication, your request will be first going through the security guard, and then you will reach out to another security guard in another building, considering every building has a security guard, and then we will, let's say, communicate to apartment number 1 here. What I am depicting in the second flow is a cross subnet communication. It is still within VPC, but now it is happening across the subnet, and in this case what is going to happen, you are subjected to one security guard. He or she should allow you to go outside, and this person here should allow you to come inside. So that's how the communication would be happening. What security guard is representing here is representing a network ACL, right? Let me write down it here it into notepad. So security group is what I am explaining here is equivalent to your apartment door, whereas network ACL is equivalent to your security guard. And that security guard is protecting the whole building, whereas your door is protecting that apartment. Right? Hope you get the idea. So depends on what your use case is. You would use both of them probably, and then you will configure different setting in the configuration of the security group and network ACL. Let's go ahead and see this information. By the way, one important information, you can't launch an instance without a security group associated, and you can't create a subnet without a network ACL associated. So that will always be there. If you remember our initial discussion, there is always a security group created as soon as you create a VPC, and a network ACL is also created as soon as you create a VPC. So that would always exist. Let's see how it is implemented. So in this architecture, the network ACLs are protecting your subnet. See this one. So this is where my network ACL is attached, and it is protecting the whole traffic. Anyone trying to come out of the subnet, anyone trying to enter into the subnet, they would be subjected to the security guard. Right. Now, what my security groups are doing in this situation, security groups are like this. They are associated with subnets here. And obviously every subnet can, they are associated with the instance here, and every instance would have a security group like we see here. So there is a security group associated with every instance, and if communication is only happening from C to D, it is only subjected to security group. But if the communication is happening from, let's say, D to B, it is subjected to this type of traffic pattern. So hopefully this thing is clear. I'll show you all this explanation into console in a minute, but let me try to bifurcate them further, like what these two things are. So first difference between security group and network ACL is security group is applied at the instance level. So this is my instance, and I would associate a security group with it. So we represent security groups like that. This is my instance, and around it there is a security group. Technically speaking, you are associating that to a ENI, a elastic network interface. So your instance would obviously require a network interface to communicate. It can have multiple network interfaces also if the need be. And if you want, you could have your security group also, which will be protecting these instances. And you can go ahead and say, hey, I would have a different security group for one ENI and a different security group for another ENI. That is also possible. So I would say security groups are applied at a ENI level or an instance level, whereas a network ACL is applied at a subnet level, right? Let me show you these things into the console so that it would be much easier for you to relate to. So I'm coming to a VPC management console. I'll open that dashboard here and we will see things from there. Here is my AWS account where I'm logged into. I am into a VPC and I am first going into the security section here and I will check network ACL. The default network ACL already exists, as I said, and if you see this one, this is my VPC which we created and this is my default nickel. Let me put a name so that it would be easy for us to remember it. Default nickel VPC 01. Now see this is associated with 4 subnet and we have only 4 subnet inside this VPC, so it is by default associated. You do not have to do anything. Let's talk about security group. If you see this thing here, I have done some extra work and that's why I'm additional security group. But if I try to filter this security group based on a VPC ID of my default VPC, my VPC01, you could see there is one security group created, which is security group named default, and this is a default VPC security group which was created for me. Now, what kind of settings and configuration I can do inside, I'll talk about them in a minute, but we have to think about one more concept here that is called stateful and stateless. Security groups are referred as a stateful mechanism. I'll explain that through an example in a minute. That means response is always allowed. So let's say this is a security group. Maybe you created here a rule which says outbound access. By the way, both type of rule can be created, inbound and outbound. If I said outbound, I am allowing every port number 80. Just give an example. If I allowed this outbound port number 80, this request from my instance here would be going to somewhere into web, and some web server would respond back, and that web server's response would be allowed to come in, no question asked, because this was requested by instance internally here. So this is a stateful behavior, whereas network ACL is stateless. Let me give an example here to relate these two concepts. Almost everyone has gone through passport control. An immigration process can differ from country to country. Let me give a brief idea here about UK immigration and India immigration. In UK, you have to go through immigration only when you are arriving, right? So when you land on any of the airports in UK, you would go through immigration officer. They would verify your documentation and then they will allow you in. While you go out, while you are leaving the country, there is no immigration check required. You could just get your boarding pass and then board the plane and go out, that's all. No immigration check is required while departing from UK, but in case of India, things are different. In India's case, you would have to go through immigration on arrival and you have to go through immigration on departure also. So in both direction, there is a check happening whether this request or whether this person should be allowed to go out or not. So the UK immigration is a stateful. They consider that, hey, if we checked you while you came in, if you are leaving, what is the need to check you, right? We allowed you legitimately to come in and you are now leaving, so there is no check required. Maybe they have a different concern than India, but India says, no, we would always perform checks in both direction, whether you are arriving into country or whether you are leaving the country, both direction checks would be performed. That is stateless. Now, why it is use stateful and stateless? Let me give an example. So consider that this entry, this entity here, whoever it is, let's say this is your filter or this is your security mechanism, it remembers that, hey, you were A, you went out, and you are coming back, or response of that is coming back. So it tracks the state of the response, and that's why it is called stateful, because it is keeping track of the state of the request which went out, and when it comes in, it will be allowed in. Whereas a stateless system says, I won't retain any local information. I would treat every traffic independently, whether it is a request or whether it is a response, I don't care. So network ACLs are stateless. Idea here is, if you have created a rule to allow a traffic from network ACL, even if its response is coming in, you have to create a rule for inbound access, whereas outbound access in both direction, you have to allow the traffic. Whereas in case of stateful, you just allow traffic in one direction, whether inbound or whether outbound, and whenever the response would come, it would automatically get allowed. So you do not have to worry about intentionally creating additional rule for this type of traffic to come in. So don't consider it is only for inbound or outbound. I am writing here response. Now response could be request, incoming request, response could be uh, for the incoming request, or response could be for the outgoing request, doesn't matter. Response will always be allowed. But in case of network ACL, you would need to create the rule in both direction for it to work properly. Okay, so hope this thing is clear, and we will then talk a little bit more on what are the default values on these things when you create these things. Now let's see this. This is important and people feel confused here. Default rule for default SG. Default SG is something which is created when you created the VPC. What it says all inbound is allowed from the same SG and all outbound is allowed. Right. Let me show this thing and it would be easy for you to relate to. Let me go back to console, and here I would check the default security group which we have here. Let me go into inbound setting. What it says inbound's name, then it says security group rule, then it says rule ID, then IP version, traffic, all protocol, all port range, and from the same security group. This is the same number 4D6, and this is the same number 4D6 here. So what does it mean actually? If I have to draw this thing to you, it means that security group is this one. This is SG, let's say 01, and SG01 can be associated with multiple instances. A pictorial representation of that association would look like this. So I have three instances, A and B and C, let's say. And if I have not modified anything and I have kept the default security group, they would all be able to communicate with each other. Shouldn't be a problem at all. That's what we mean by allowing traffic from within the security group. So that is the default behavior of the default security group, that it is allowing traffic to be coming from inside, and then that is default traffic. Source is this. If traffic originated from anyone from this security group, we would allow it. That is my inbound rule. Outbound rule here says, let's read this. No name, security group rule ID, that is fine. Then IPv4, all traffic, all protocol, all port range, destination 00000. What does it mean? That means all outbound traffic is allowed. As soon as your machine boots, and if it wants to communicate to outside world, it would be, provided there is a public IP and route table configuration. Let's say if it exists, then your instance would be able to initiate requests to go outside, and response to those requests would be allowed to come inside. But somebody won't be able to initiate connection from the outside world. So if I draw this thing again on the blackboard, this is my instance here. This is the security group associated with that. It says I would allow everything outside, right? And I would allow a response of that also. But if somebody from outside is trying to directly access any of the resources within here, I am not going to allow it, that rule doesn't exist and we have to create that rule if we want to allow the traffic. Let's say we decided that we are going to host a web server here. If it is a web server, I would expect people to talk to it on 80 or 443 port number. So on the security group, I would be allowing port number 80 or port 443 so that external entities can communicate to my instance. Right. Okay. So let me go ahead and refer the thing back into our slide deck. So what we were discussing, we were talking about default behavior. Default behavior says that all outbound is allowed and all inbound is allowed from the same security group. That is for a default SG. Now, what if I create a new SG? Let's go ahead and create a new SG and see what happens there. We would be able to relate these things there. So my intention is that, hey, I'm looking to create a security group. Okay, let's create a security group. Let's call it my web SG, right? I have to select which VPC it would be part of. So I could select a VPC from here. That is my VPC01 Ireland. And see, there is no inbound rule there by default. I could add it. We'll do that in a minute. But outbound rule exists which says all traffic, all port ranges, custom, which is this is internet, and that rule is already there. Obviously, you could delete it if you want to, but this is a behavior of a new security group. Yes, we need to give a description. So let's copy paste the same description and I say then create a security group. So now my security group is created. So one I created and one which existed before when the VPC was created. So that is how the difference is. Let's talk about network ACL now. In network ACL, all inbound is allowed, which is default, and all outbound is allowed. Like this one is doing nothing technically. Means this security guard is new and we have not instructed him or her to do anything, and they are not doing at all anything. They are allowing everyone to go in and everyone to come out, no restriction. And think that's why people call it, this one is a transparent nickel, because this is not doing anything at all. It is just sitting there and allowing all traffic to come in and all traffic to go out. Let me show that default nickel to you. A rule already exists in that, and we can modify that default nickel if we want to, or we could create our own nickel if the need be. So I'm now going to my default nickel. Let's see the rule here. So inbound rule says 100. In nickel we have rules with number. So this is my rule number 100. Type all traffic, protocol all port ranges from source 000, which is anywhere, and which says allow. There is one more rule at the bottom which is called default rule. This is represented by a star in the rule number. So this is a rule which is always there at the end of network ACL. So this says I would block all traffic if it is not following on this category. But basically this category will always be applicable because we are saying we want to apply this to all protocol, all port range and from anywhere. So this second rule, which is star rule, the default rule won't be applied. It will always be applying the first rule here, right? So that is my inbound rule. And similarly, I have an outbound rule, and outbound rule is also the same, that it is allowing all traffic, all port, all destination, no issues at all. So that is my default nickel. But let's now create a network ACL. So I am creating a new nickel and I would call it my nickel 01. I have to select a VPC for it. I would select it and then I would say let me create it. So once I have this nickel created, let's see what happens inside it. This is my nickel. I would say inbound rule. No rule is existing here for allow. There is always a deny rule, which is the default rule present. This one was in inbound direction. Let me go to outbound rules, and in outbound rule also there is no additional allow. There is just a default deny available, and that is existing here. So default rule for a new nickel is all inbound is denied, all outbound is deny, and we have to then open up that network ACL so that it can access other services, or it would allow traffic from different source or destination. It is purely up to me how I want to configure that setting. I'll talk more on network ACL and security group because there are a lot of questions you could expect into your exam on this specific topic. Now, one more thing here. One instance can have many SG assigned. What I mean by that. So this is one instance. I could say, hey instance, I am going to associate you with SG01. Okay, no problem. Hey instance, I am also going to associate with SG02 and SG03. So that is possible. You can have up to 5 security group assigned to an instance. You can assign doesn't mean you should assign, but yes, this is a technical possibility. If you need, you could have up to 5 security group associated with an instance, whereas your subnet can only have one network ACL, right? So what we mean by that, let's go back to example of the building. On that building, there would be one security guard for the whole building. Now, in your apartment, you could say, hey, I am little paranoid and I would have one door, I would have another door, and I would have another door before somebody can meet me. So that is possible too. That is your security group, right? So one instance can have many SG, but one subnet can have only one network ACL. Now, what happens if there is a situation where there are conflicting rules? Let me give an example. Let's say, or maybe tell me if you think this is possible or not. What if I have a rule, because we can apply multiple SG, so I have SG01 applied, which says allow port number 80. And I have SG02 applied and which says deny port number 80. What would happen? Now most of you would be thinking deny would take precedence. Security group do not have deny statement at all. Only thing you could do is allow. So if this was allow, then it would be having no issues at all because it is allowing. Or if security group says 02 says allow 443, the result would be that the both of the 80 and 443 port would be allowed. So there is no deny statement into security groups. Let me quickly show that to you. So I go back to my security group, and here I go ahead and to my WebSG, and I want to add some rule, let's say for outbound, and I want to say edit outbound rule. See this? I do not have any option to say what type of traffic is, sorry, what type of action is it, allow or deny. I could just say what is allowed. So it just has allow rule, it doesn't have deny rule. But network ACLs are different. In a network ACL, if I go, I should be able to see a deny rule also. So if I'm going ahead to my NACL and I say I want to edit outbound rule, I should be able to add a new rule, and here I could select either allow or deny that traffic. So it will depend on it. Right. So hopefully this thing is clear that we could have a NACL which could have allow and deny both statement, but your security group would have only allow statement in that. Right. Next thing, order is not important in security group because it is just additive action. Security group 1 allows 40, another allows 443, another allows port 22. They would all add up. But in network ACL, order is important. You have to define it in a way that your first ordered rule will be something which you want to allow or deny, and then other rules will be processed. Let me quickly go to console and show you this concept here. So I am on network ACL. Let's say I want to allow some traffic in. So I have to create a rule, and I would then create a new rule here. Let's say I want to allow port number 22. So I'm putting a rule number here 100, and then I say I want to allow a specific port number. Let's say SSH is 22, and I could specify source is 000, means everyone is allowed, and then I could add another rule, and this time I could say this is 101 rule, which will be still same for SSH, but this time I would say I am going to deny. So one rule 100 says allow, 101 says deny. What is going to happen here? That we would be processing, means this network ACL would be processing the rules in the ordered listed. The lowest ordered rule will be processed first. So every time the traffic comes in, first this rule would be checked. If it is port number 22, request coming from anywhere, it would be allowed. The second rule will never be checked. So order is important in case of network ACL. In security group, order doesn't matter at all. So hopefully this topic is also clear to you that order is not important for SG, but for network ACL, order is important. Now this video will go a little bit further, like 5 more minutes. I want to finish it up. I want to talk about one more important topic here, which is source can be IP range port, or a network ACL can have only IP port or IP range. Let me give an example here so that you could relate it. Let's talk about one situation. I want to create a security group, and in that security group I want to say, hey, my request is, or I want to allow traffic. Let me see if my text color is coming up. Yes. So we want to allow HTTP from anywhere, right? Anyone should be able to access this machine from anywhere on port number 80 or HTTP port. Done. And what I want to allow ICMP, which is your ping request, right? So this ping request uses a protocol which is your ICMP protocol. That protocol is what we want to allow, but only from instances within the security group. So if this is my SG01, and if I have instances here which is A and B, I want A and B to be accessed by outside bodies or on port number 80, and I want communication between these two to only happen on port number ICMP protocol, and that would allow A and B to communicate. Now before that, question to you, is communication between A and B is currently allowed or not? Now, the impression which people get with this kind of diagram is that my security group is encompassing multiple instances. That is true. But if I have to redraw this diagram properly, I would put a diagram like this. I would say, hey, you are instance A, you are instance B, and security group 01 is applied on both of you in this fashion. So this is my SG01 and this is my SG01 also. So both would accept port number 80 traffic, right? But there is no rule currently in that which would allow communication across them. We want to create that rule now. So I will show you implementation of this architecture or this security group where we will allow HTTP from anywhere, but allow ICMP ping traffic only from within the instances of the security group. Let's go ahead and implement that solution into console. That would give you the idea of power of security group, that how you could control different type of traffic. So let me cancel this one. Let me go back to my security groups, and we would be then creating a security group there. Let's call it demo security group. I'm creating it again here. I will call it demo SG01. Copy the detail into description too because we would need it. I would keep it into the VPC of my choice, which is VPC01 Ireland, and I am creating a rule here, inbound. Here I say very specifically, hey, HTTP traffic is allowed. Done. So custom, I would say okay, IPv4, or I could say just anywhere, and it will automatically pick up 00000. So that is one rule which I have created. Let me first create this security group. So as soon as the security group is created, it gets a security group ID which I am interested in copying right now. So one rule is ready. What this rule would say, it would allow all traffic in this security group on port number 80. But my request is that I want to allow ping within security group. So let's go ahead and create one more rule for that. So I would create one more rule. and this time I would allow ICMP traffic, right? So this is my ICMP traffic. This time I would say you would allow ICMP, but if I put here anywhere, which means anyone can ping it, I don't want that. Instead of that, here I would say custom, and in custom I would put the ID of the same security group, which means it is referencing itself. So that would allow traffic from within security group on port number ICMP. ICMP doesn't use a specific port here, so it is just using ICMP protocol here. Done, and I could now save this rule. Let's read what this rule is now creating. So this rule says I would allow HTTP from anywhere, but ICMP would be only allowed if it is coming from the same security group. So this is a very powerful feature where you could reference the same security group within itself, or you could reference that security group with others also. Let me give an example of that. Let's say we have a standard 3-tier architecture. 3-tier architecture is mostly deployed using a web server or a group of web server, and then application server in between, and then database servers. Let's consider these are all our AWS resources, and all of them have a security group assigned with them. Let me use a different color so it would be easy for us to relate. So this is a security group here, another security group here, another security group here. Let me give it name so that it would be easy for us. Let's call it SG Web. Let's call this one SG App, and this one SG DB. Okay, what kind of rule I would be creating? So web server would have a rule which will say allow, let's say 443 from anywhere, right? That would be useful rule for a web server so that it can accept traffic from anywhere. But I don't want anyone to talk to my app server. I want only web server should be allowed to communicate to app server. So what I would do in this case, I would now create a rule which will say allow. Let's say my app server is running on port number 8080. Allow 8080 from, and here I would say from SG Web. What it is saying now, hey, first request coming from anywhere, no problem. If it is coming from 443, we would allow it. But if the request now comes from this web up to this and only on port 8080, I would allow it, otherwise I won't allow it. If somebody externally is trying to directly communicate to this app server on port number 8080, it won't be allowed. So what I did, I referenced the security group of web server for a rule created into a security group of app server. And probably you have got an idea now that what entry would be existing into my security group DB. In security group DB, I would just say, hey, allow, let's say this one is 3309 port number, right? From, and that time I would say SG app. Sorry, so SG app. So only SG app would be able to communicate to database. If somebody is directly trying to communicate to my database server, that somebody could be even web server, those requests will be denied. They won't be allowed to access. So what I did here, I have tightened the control of who can talk to whom and on what port they can communicate, what can happen. So this is a better approach. This would give you a more controlled way of delivering your application security and designing your security in this specific manner. So hopefully this thing is clear that you could reference that same security group or other security group into the rules, and that's what I was trying to explain on the last point on my slide. Let's read that again to reinforce what we just talked. So in security group, your source can be IP, source can be IP range, port numbers, or security group reference detail also. Network ACL doesn't support that. In a network ACL, your source for filtering can be IP, port, or IP range only. So that is the difference between a security group and network ACL. I hope you understood it. Sorry for a little longer lecture. I was hoping to finish it in 30 minutes, but I can clearly see it went up to 40 minutes, but hope you have got a better idea. So I'll talk to you into the next section and we'll talk about more networking stuff. Thank you.